The topic that we are going to be discussing today is transport level security. When we are thinking about network security, one thing that we can sort of identify is like it is mainly about what happens when the data is in motion. So data is going from one place to another. So that is where our focus on network security comes about. So with that, we can look at transport level security through sort of few different lenses and few different ways that we can achieve that. So when we talk about transport level security, we are mainly thinking about in the context of how uh, uh, these networks are used in World Wide Web or in a web environment. So that is one of the first places where we start thinking about transport level security. So in a network, in the internet, that is to say. So that type of a network environment is what we are talking about. And if we particularly think about such an environment, um, such a sort of internet, web, World Wide Web environment, uh, we can identify a number of aspects where security would be important. So, if we think about World Wide Web itself, it is an application that runs on top of, or it is a set of applications that run on top of TCP/IP network. So the networks are there. So the established networks will be there, and this is one of the things that we can do on top of those networks. And in that context, there are a number of things that we have in that environment that can have different security implications. Say, for example, we have we will have servers. We have different content that is available through those servers. Then we have quite a lot of software running on those servers, different different web servers and other software applications. And in many organizations, that web presence would be something that is an external facing interface. So, for example, that could be one of the only places through the network, in the network, that is outwardly exposed. And many of the users who will be using um, these web-based services are people who don't have a lot of security-based knowledge or knowledge around security matters. So the issue with this combination is that there are a number of ways this environment can be exploited. The circumstances in this environment can be exploited in a number of ways. So as we saw, like all the different software components, servers, and all these things, they can have a number of different security flows that can be exploited. The way that it is set up, if one of these things are exploited, it can further lead into other parties getting into the organization's computer network. Because again, if the web servers sit in such a manner, that could be a problem. And also the end users could be exploited and tricked into doing things that they should not do. Either they uh, hand out their login details to parties that should not have them, or they that type of issues are also there. So this is sort of the background from which we will have to think about this problem. Then, in that context, we can look at a number of different threats that can be there in the web environment. So we can look at the web environment that we looked previously, and we can see what are some of the different threats that we can have. And we can also break these threats down into a number of different categories. Threats that impact integrity, threats that impact confidentiality, threats that impact availability or the nature of sort of denial of service type attacks which impact availability, and also authentication related threats. So in terms of say, if you think about threats, say, that are impacting integrity, so these are things that can modify user data. So anything that can sit in the browser and make changes, or make changes when the message is in transit, so that type of thing. Confidentiality is again any sort of thread that is sitting somewhere and stealing information either from the client side or either on the server side, or possibly on the communication path as well. Um, Denial of service or availability uh, attacks targeting those threats can be around sort of typical DNS attacks like flooding with requests, or disabling other things, disabling the server side devices, those type of things. Authentication type threats are when requests are coming impersonating legitimate users, some form of forgery type activities, so these are also some possibilities. Then with each of those things we have different consequences. So when we say integrity, so that is where we are not sure whether the data that is available to us is correct or not, so we can't be sure about that. Confidentiality is when we have issues with privacy, so our private information is now exposed to people who should not have them. Denial of service attack is going to prevent us from using the system or information or data. And when authentication fails, wrong parties can misrepresent users. Again, the trust is going to be the, the main sort of consequence of that. So we can build different countermeasures for these, like using cryptographic methods, certain encryption mechanisms. So a different options will be there to handle these different types of threats. So that is something that you can look into later as part of an activity. So if we look at how this communication is going to happen within the network, and this is something that you would be familiar with uh, from your understanding of the OSI layer. So we have particularly when we talk about the last four layers or the bottom four layers of the OSI layer, that would be relevant to this discussion. And there, what we are particularly thinking about is what are some of the different protocols that we can have for security. So, for example, at the network level, we can have IPsec. Uh, that is a topic that we could possibly discuss in the later part of this course in a different lesson. Then at transport level or transport layer level, we can have things like SSL or TSL, which we are going to discuss today. And then at an application level is where we have things like KBROS or other protocols, again, security protocols, which we are not discussing today, that can be covered later in other discussions. So we are mainly focusing on the communication path that is relevant in the transport layer. That is our focus for discussion today. So now let's look at what is SSL or TSL in the context of transport layer as protocols at the transport layer. And TSL, the name itself is Transport Layer Security Protocol. Um, so it is the latest of the two, SSL and TSL, and it has become the de facto standard for internet security these days. And the main goal of this protocol is when we have two entities communicating, how we can achieve confidentiality and integrity between those two communicating parties. So the threats that we identified around confidentiality and integrity, these are the two things that we can try to resolve when we are using the TSL protocol. So when we say these two entities communicating entities in the context of web, it is mainly the browsers and the web servers. Or in the modern use case, it could also be the various applications, particularly in the mobile environment, various applications on your mobile devices and the corresponding web servers. So they are going to be the two communicating entities or two communicating parties at the both ends, and they are going to communicate through this transport layer security protocol. And this TSL protocol itself is developed based on SSL protocol version 3. So it is largely a similar protocol design, but at using different algorithms. Different cryptographic algorithms are slightly different in places. So we'll look into some of these differences in today's lesson as well. And these days, it is expected that all the browsers that we would consider as modern browsers would support TSL and possibly later versions of SSL as well. And they are, in a way, they are phasing out the older versions of these both of the protocols as well. So this list sort of illustrates the various different protocols that we uh, can discuss in this context. So it started with SSL um, um, in around 94, but the SSL version 1 was never used because it was rather an internal design at Netscape, which was a browser that I don't think any of you would have. I mean, like these are before your time in the world. So then SSL2 was there. Even that was not a great protocol. It never became much of a thing. Had a lot of issues, and version 3 uh, became became much more widely used, and it was being used for a long time thereafter as well. Um, TLS version 1 came about in 99, but now we have version 1.3, which came about around 2018. But so that also sort of replaced TLS 1.0 is no longer the de facto standard, and many browsers don't even support that. They would require most communications would require you to go to a newer version of TLS as well. So that is where we have sort of the protocols lay at this point in time. So, but if we look at these protocols uh, and look at how sort of the TLS is defined and what is its context in the world is. So it is one of the most widely used security protocols because it is used as the backbone for security in web communication, and web is very widely used. Um, it is it has become one of the most widely used security protocols. So it is defined in a particular RFC that can be referred when needed. And it was in a way it was an open standard replacement to SSL, because SSL was still even though it was sort of an open protocol, it was still a commercial protocol from Netscape. So it was still sort of had that thing. So TLS was an open implementation of uh, that, and one of the main sort of advantage or the difference that we have with TLS is um, because it functions at the transport layer level, uh, it can be transferred to application. So the any application that can run on top of TLS can change. So it has no dependency on that. So applications don't have the dependency on what is the protocol below at the transport level, and it can be the communications can be established like that. And most modern browsers, uh, any device that is able to communicate to the internet, to the web, would implement TLS, and it has become such a widely implemented, widespread standard overall. So now let's briefly look at the sort of the underlying architecture of TLS, how this protocol um, works. So there are two concepts that we have that are important in the TLS architecture. One is the TLS connection, and the second one is the TLS session. So the TLS connection is the one that provides connectivity between two ends. So that is the communication that is happening between the two ends, and these connections can be somewhat temporary. So if I'm sending something to the other end, so that communication is a connection. So it establishes and sends that information through. So that is what we identify as a connection. So each of the information flow can be identified as a connection. And each of these connections are associated with what is known as a TLS session. And this TLS session is more like uh, an association between a client and a server. So this is where these two parties are established as the two communicating parties. So that is established through what is called the handshake protocol. So they go through this handshake protocol, establish some cryptographic parameters, cryptographic security parameters, and once those are established for a particular TLS session, then they can be used repeatedly for multiple connections. So because like establishing these security parameters requires quite a bit of communicating back and forth, going through this handshake protocol and all requires quite a bit of work to do that. So what you do is you first communicate with the server. So if you are the browser, you communicate with the server, you send back and forth some information and all that. You establish what is known as this TLS session. So now you have this session established. So both parties sort of identify. So I am the browser, that is the server, and each other know the information. So hereafter, they don't have to every time talk about this background information about who is the browser, who is the server, and all that. They can establish these new connections and continue communication. So that is where these two concepts come into play. The session concept establishes the underlying requirement for the security protocol, and the connection establishes the way to use that underlying security established security to communicate in a sort of a repeated manner. So those are the main two concepts that we will have in the overall TLS architecture. So we will not be going into like too much detail about these different parameters at a connection level and also at a session level. But we can look at some of the key aspects that we can observe in these. So when we say talk about connection state parameter for each of the connections, um, they will have uh, some of the cryptographic parameters uh, from both client side and server side. Uh, and then again, they will have these keys from both the uh, client side and the server side. Uh, and they will have certain mechanisms to keeping track of these communications. So that is where they will have these initialization vectors and sequence numbers and so on. We will look at the how the protocol is established and all in a bit uh, today in a few minutes. But these are some of the things that we will have at a connection level. And at a session level, we will have, this is where we have most of the high level cryptographic parameters. So we have the PS certificates or cipher specification or master secret. So these type of information will be established at a session level. So that is, so uh, as we identified, session is what will be established first, then connections will be established within or for um, different sessions. So this is the set of parameters that will be established first. So if we look at the TLS protocol, uh, it is something that runs on top of TCP. So, so, so it functions on top of TCP IP. So IP TCP. So that is where uh, 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 we have this protocol. And TLS itself is not a single protocol. It, in a way, it sort of functions at two levels or two layers. So we need to have a record protocol, and on top of that, we can have sort of a number of protocol like the heartbeat protocol, handshake protocol, all these different things that are necessary to establish the overall TCP protocol. So it's a combination of these two or these sets of protocols is what we identify as TCP. And on top of that, we can have any upper layer protocol. So at the upper layer, we have the independence to choose any of the protocol. So any of the protocol can be operating at that level. So we will first start looking at the TCP record protocol. So basically, the TCP record protocol is the one that is essentially providing the core services of the TCP or of the TLS. Rather, the TLS record protocol provides both confidentiality and integrity. So, this is what provides these two main sort of the core functionalities of the protocol. So, once a certain shared secret key is established between the two ends, then it will use that shared secret key to provide encryption. So end-to-end encryption using uh, uh, any of the encryption protocols. So again, it doesn't have to stick to a single encryption protocol. We can choose between a number of different possibilities like AES, DES, a number of 3DS or something like that. Then it has the message integrity aspect. So again, with the shared secret key, this can again provide a message authentication code or the MAC. So again, this is like the signature component of the communication. So for example, it can use HMAC with the shared secret key. So these two in combination are the sort of core things that we expect from this protocol, because at the beginning when we said we are using transport level security, the two things that we wanted is confidentiality and integrity. And this TLS record protocol is the one that provides both of these services. So if we go into this a bit more in a bit more detail, we can look at how this is done. Say, for example, we start with the application layer. So we start with the application layer or the any sort of data that is coming from the application layer. So then what we will do is we will have to fragment that application data into a number of pieces. So we break that down into a number of pieces. Then if needed, if possible, if requested, we will also compress that data. So now that overall data is now broken down into small pieces. Once that data is broken down into these parts and compressed, thereafter we can generate our message authentication code MAC. So this is the part where we add the integrity aspect. So this is the MAC is the one that is going to add the integrity aspect. Then after that is done, we can encrypt the whole thing. So the compressed message and the MAC, both of them together can be compressed. So we can do that to the whole thing. And once we have done the compression part, then we can also add any sort of corresponding header. So to the message, we can add any TLS specific header. So that is where, say, for example, in the TLS specific header, we can have information around the content type, version, compressed length, and all these things are included in that. So that part, the record header part, is something that is not encrypted. So that will not be encrypted. The other part can be optionally encrypted. So the encryption, rather, it will be encrypted. So whereas the record header part will not be encrypted. So that is the overall TLS record format. So it will have the header information, then it will have the plain text and the MAC both encrypted, and the plain text can also be optionally compressed. So that is the way that we will break down our application data. So when we receive a application data to be communicated, this is how we will break down and communicate. So in addition to the components that we identified as part of the TLS record protocol, there are a number of other protocols that are part of TLS. So we have what is known as the change cipher spec protocol. We have the alert protocol. We have the handshake protocol. And we can also have any other upper layer protocol like HTTP that is using TLS. So we will briefly look at each of these things and how they correspond to the overall establishment of a secure connection or secure communication. So first, if we look at the change cipher spec protocol, this is essentially a very simple protocol. Even the payload is very small. It's 1 byte payload that is communicated. So what it does is it essentially changes the cipher spec. So when we establish, so when we are doing the initial handshake to establish a connection, so establish a session, so at the very beginning, and also possibly uh, uh, we'll look at how this is the overall handshake protocol is done. We will look at that in much more detail. But this is where the change ciphersec protocol comes into play. So it is one that is established between the client and the server to specify what is the cipher spec that they are going to use for their communication. So, for example, in the previous point, we said like there are different possibilities for us to use different encryption algorithms and things like that. So, and different cipher standards and all. So that's what will be established through the through this protocol. Then we have the alert protocol. So again, this is again a way to communicate between the two entities around any sort of alerts. For example, when a connection is terminated or when the connection is to be resumed. So that type of aspect can be communicated through this protocol, and it can also communicate information around if a communication was received but there was some issue with that, if an unexpected message was received, if the message authentication code was bad, so because it was not be could not be authenticated, if the compression fails or decompression rather fails, they were not able to decompress the message at the receiving end, if the handshake is failing. So if there are any issues around this communication, that can be further that particular specific problem can be communicated through this TLS alerts. So the TLS alert protocol is there for that purpose. Now we come to the most sort of important and sort of complex part of TLS, which is the handshake protocol. Because without the handshake protocol, we will not be able to establish a secure connection. Because in the web environment, what we have is two entities, a client and a server, both of which don't have any prior introduction or any sort of established connectivity between them. Not like PK or like public. In public key cryptography, we have this public keys and private keys shared between the entities, and they can communicate. So these are things that we have covered previously in security. So whereas with TLS in this environment, say for example, if you are going to a website, that web server and your browser don't have any established uh, communication done before that point. So each of them will have to authenticate each other. So they both entities need to sort of identify and authenticate each other. Then they have to negotiate some methods for doing encryption for the confidentiality part. They have to negotiate and do some identify some algorithms for the integrity part or the MAC part. They have to create the corresponding cryptographic keys, and those should be exchanged. So everything that is needed to establish a session will have to be done, and then establishing a connection can be done. So this basic establishing part will be done through this handshake protocol. So the handshake protocol should happen before any secure communication can be happening, and any of the record protocol activities can begin. So this should happen at the very beginning before the actual TLS communication can start. So this is essentially the handshake protocol. It has um, a number of steps. Uh, so not to be confused or anything, we will look at these in a bit more detail uh, uh, eh, with each phases. So what we have is we can sort of divide this into four phases. So that is um, sort of starting with in the first phase we establish some security capabilities, then uh, server authentication and key exchange. So the server will send some information to the client, then client will send some information to the server, and then with those shared information, sort of the finalizing uh, of that communication and the handshake protocol can establish the overall session there. So we can sort of break this overall handshake protocol into these four main phases. There are a number of different messages that will be part of the handshake protocol and number of parameters and all that. We are not going to go into details of those. But let's look at the first phase, the handshake phase one, which is establishing security capabilities. So in this phase, what happens is, so when you go to a website, you connect to the web server, and then your browser will send a client hello to the web server. So there the client is sending the first hello, and the server will then send a hello back. The server hello is the response to that. So this is where you establish things like what is the protocol version that you are going to use. So we are going to use TLS 1.2 or TLS 1.3. So you establish that protocol version. You establish a session ID. You establish what are the cipher protocols that you are going to use or algorithms that you are going to use. What is the compression method, and what are the initial random numbers. So this is again a random number that is shared between the two entities, which will be further used for the establishment of these other cryptographic parameters. So that is the basic two steps in the uh, client hello and the server hello. So client will send some information asking, I'm going to communicate using this. Is that okay, kind of a thing? And the server will say, okay, we can use these things and communicate between each other. So that is the basic. So setting the baseline parameters. Once those baseline parameters are done, the server can now send some information uh, 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 across to the client. So the server can send a certificate, a key exchange, and then also request a certificate from the client. So it can send its certificate, request and a key exchange, and also request a certificate from the client. And then it can conclude saying server hello done. So that is to say it has communicated its part. That is the server authentication and key exchange part. Then on the client authentication and key exchange, the client can send the certificate if a certificate was requested. Then client can send its key exchange, and it can also send the certificate verification for the server certificate, the certificate that was sent by the server. Then finally, uh, we can go through the change cipher spec to establish what is the um, um, cipher suit that we are using and finish the communication, and both parties will finish that communication. and that will conclude the handshake protocol. So, is that a bit too much of protocols? Uh, so, it is one of the important protocols when we think about um, network security, because like one of the most common networks that we will deal with is the internet, and TLS is, we can say, as the backbone, security backbone of most internet communication. So it is essential that you have a better understanding of that underlying protocol. But it's a bit too many stages that we have in these protocols. But other than that, these are fairly straightforward protocols as well. So, yeah. So then we also have what is known as an abbreviated handshake. Uh, um, so the abbreviated handshake is where we have uh, when we have TLS connections, we already have an established TLS session. So when we are doing handshake for each of the connections, we don't have to go through the all handshake thing. We can share the existing session ID, and if both parties agree on using the same session ID, then all the other phase 2 and 3 of changing information can be skipped. So what we essentially do is, say, in this four phases, when we are saying client hello, if we can also share the information about the session that we want to use, because when we want to establish a connection, there's already an established session. So if that information is shared, and if both parties agrees to use the same session ID, then we can skip phase 2 and 3 and go to phase 4 to complete the establishment of the handshake. So then another interesting aspect with TLS is that we are doing some cryptographic computations, because we are exchanging these keys and certificates and all these things, and some cryptographic computations are done at both ends, at the server end and at also the client end. So what we end up doing at the end is we end up creating a shared master secret. So these are not this is not like where in public key cryptography we have the certificates, rather the keys, the public and private keys at both ends, and we use each others to establish the communication. Here we have a shared master secret, so both sides have the same secret. So we essentially have a symmetric encryption. When we are doing encryption, we are using symmetric encryption at that point. So this shared master secret is something that is generated for each session. So it's a session per session information, and that per session information is uh, established through through a sort of common calculation. So that is, first a pre-master secret is shared. So a first part of the secret is shared. Then both parties will calculate the master secret in a certain manner. So that is what we would identify as sort of calculating the core cryptographic aspect of these communication. So when we look at the cipher spec for a TLS connection, we need quite a few different cryptographic parameters. So we need a client write max secret, server write max secret, uh, client write key. Likewise, we have both for client side and server side, and all of these things are generated from that common master secret. So that common master secret becomes the basis for all of these different cipher cryptographic parameters. So if we have a particular length of the master secret, then we have a set defined way of breaking that down into pieces, and each of the different sequences are used for different parts of these cipher specs. Then there's another protocol that we identified as the heartbeat protocol. Uh, this heartbeat protocol is there mainly to indicate uh, um, it's sort of a periodic signal to indicate the normal operation or the normal communication between the two entities or two parts. Uh, uh, um, it is essentially to say, it is essentially a uh, still alive type message. Um, so it says, okay, the sender is still actively available for further communication. And it also serves the purpose of particularly other security mechanisms like firewalls and others who may close down idle connections, or if a connection is established between two entities and if that connection is not being used for a period of time, that connection may be considered as no longer be used if it is beyond a certain idle period. So to avoid that one also, these heartbeat protocols can be useful. So because it periodically sends a message, and the connection will be kept alive continuously. So it again, it is also another protocol that runs on top of the TLS record protocol. So this is again uh, something that is like some of the other protocols that we looked at. This is also something that is beyond or above the record protocol. And it again has two messages. One is a heartbeat request and a heartbeat response. So it will be appended to the record protocol when it is communicated, rather record protocol message. And that heartbeat protocol is essentially established using the phase one of the handshake protocol, which is whether to use the heartbeat protocol, and all that information will be established using rather at the phase one of the handshake protocol. So now let's look at some of the attacks that can be done against SSL TLS type environments. So when we say we establish or we use TLS or SSL to establish transport layer security, there are also going to be potential threats or attacks targeted at this particular protocol, because once we exploit this protocol, or once we exploit this level, we can gain access to the network. So there's bound to be attacks targeting this. So we can categorize these attacks into a number of main categories. One is handshake protocol, attacks that are targeting the handshake protocol. Because handshake protocol is the one that is establishing this master secret. And before handshake is done, both parties don't know each other. So if you can somehow come into play when handshake is happening and somehow compromise that communication, you can further have access to compromising any other further communication as well. Then other types of attacks may target the record and application data protocol. So specifically targeting any of these other specific protocols and looking at any vulnerabilities in those protocols and trying to exploit those. Then there can be attacks on the PKI infrastructure or the public key infrastructure. So around certificates and keys and all these things, it's possible some of those can be exploited as well. And then there can be some other attacks that may not come under these categories. And what we need to understand is both SSL, different versions of SSL, TLS, and TLS, different versions of TLS. What happens is new threats will come about, and then new countermeasures will be identified. Possibly the protocol may be updated to address those things, and this goes on in this continuous evolution process. So that is why we may be looking at a particular version of TLS now, but it may be updated in a few years to address some of the newer threats and newer countermeasures that could be put into the protocol. So that's why the latest version of TLS, that is version 1.3, the main thing that it does is it addresses a number of key shortcomings that were there with the previous versions of TLS. So it improves the security. There are a number of changes. So we are not going to details of the specific details of versions of protocols. But one thing to understand is it has sort of certain advantages, or it makes certain improvements, particularly around the compression side and all these things. So there will always bound to be updates to such protocols. So that is something we need to understand as well. These are not static things that will remain unchanged forever. So now look at one of the most common sort of application of TLS, which is the name is still HTTP over SSL, which is HTTPS. But now it has been surpassed as with HTTP over TLS. So this is when we use HTTPS for our web communications instead of HTTP. So this is something that you all would be very much familiar with. And this is one of the most common uses of these transport layer security protocols, where the HTTP communication is forced to go through a TLS or a SSL or TSL secure protocol. So that HTTP communication becomes a secure communication, an encrypted, end-to-end encrypted communication. So if we particularly look at what information get encrypted in an HTTPS communication, it includes everything from the URL of the document, all the contents, all the browser aspect, any cookies sent back and forth, and all the HTTP headers. So all those things will be taken as the application layer information, then as we discussed at the beginning of the discussion today, that will be broken down into these parts, the messages compressed in authentication code added, encrypted, and sent through the TLS protocol. So with HTTPS also, uh, the connection establishment is not significantly uh, different from what we looked at when we were discussing the uh, TLS connection initiation, because we are essentially using TLS to provide that service. The only difference is the HTTP client would be the one that is acting as the TLS client. So in the case of the browser, normally the browser is the HTTP client. Now it also acts as the TLS client, providing that aspect as well. So other than that, all the communication, all the protocol establishment and everything is the same. And once the TLS handshake is finished, then the client may initiate the HTTP request and send all the information through as TLS application data. And one of the other things that can happen is when a HTTP client wants to terminate a connection, that is closing a connection, then it can first go and close the HTTP connection, and then it can also initiate a termination or the closure of the TCP connection of the TLS, because um, one of the issues that we need to understand is if these connections are not closed appropriately, or if they are sort of incomplete closures, then that could be interpreted as an attack on the communication. So, for example, if the closure messages are not sent before closing a connection, the other party may take that as there is some security issue in that communication, and that can lead to further complication. So that is why we close these connections as well. Now, let's look at another protocol in addition to TLS that can also be used for some form of transport layer communication. And this is also something you would be fairly familiar with. You would have come across this in some of our previous discussions as well in number of different modules. That is SSH. So basically, this is again a secure communication protocol and mainly providing uh, sort of network-based functions. So it can establish a number of different. You can share information, possibly send files and all that. So a number of possibilities are there with SSH as well. So we'll sort of briefly look at SSH, and particularly in the context of networking, SSH has become the protocol choice to replace something like Telnet and other sort of remote login schemes to log into various network resources. Uh, these days, SSH has become the standard to do those things as well. So that is also another reason why we look at SSH. Um, so uh, so let's look at some of the different protocols as part of the SSH protocol stack. So when we look at the SSH protocol, again we can sort of see similar to what we looked at TLS. Here also we can have a couple of layers of protocols that run on top of IP and TCP protocols. So we have the SSH transport layer protocol. Again, this is the one that is going to provide the confidentiality and integrity part, and it can also optionally provide compression. But it also provides the server authentication component. Then we have SSH user authentication protocol that provides the authentication at the client side. Uh, uh, and then also we have the SSH connection protocol that can function as an encrypted tunnel and provide sort of several parallel communication channels. So those are the three main protocols that exist as part of the overall SSH protocol stack. So again, like I don't think we need to go into specific details about how the connection is established between the client and the server because these are fairly similar in the sense not too complicated to understand. But it would start with again similar to a hello, the SSH. So the client, because anyway the client is the one normally would establish the connection with the server, so the client will send the identification string exchange. So it will send that information. The server would respond with whether that is accepted. Then there is the stage for algorithm negotiation. Again, there's a back and forth between that for that. Then there is a key exchange, and then finally the service can be used. And one of the main differences between this and TLS is here we have a public-private key pair. So here it is more of an asymmetric encryption uh, 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 communication compared to what we have with TLS. Then at the SSH connection protocol, uh, um, so there's so first so once the connection is established, then this is where the data transfer happens. So you open a channel. So every channel is like individual sort of parallel connections. We can sort of consider it like that. So we open a channel, and then through that channel you can do data transfers, and then the channel will be closed. So that is the SSH connection protocol. And then we have the user authentication protocol. So again, here we can have a number of ways to authenticate users, that is public key or password based or host based. So depending on how the server needs to authenticate, the client has to authenticate using the suitable manner. So authentication request is sent and then responded with a failure or a success. And one of the interesting and most useful features of SSH is what is known as port forwarding. And this is where what we can do is we can establish an SSH connection between two entities. Say, for example, from your computer to a server, you establish an SSH connection. Then what you can do is you can take a TCP connection and send it through the SSH connection. Say, for example, all the traffic that is coming from your browser, that you can forward it through the uh, SSH connection that you have with a server. So this is what we refer to as SSH tunneling. So we establish an SSH connection, and then other type of traffic, other type of TCP traffic is sent through this SSH channel. And we can have different port numbers to establish a number of such channels. So that brings us to sort of a summary of the different things that we have discussed today around transport layer security. So we mainly looked at a number of different protocols, particularly around TLS and SSH, and how that also corresponds to HTTPS. So the main reason for today's discussion is to give a better understanding of one of the sort of building blocks of secure networks, particularly in the internet era, like in the internet environment around web and all that. So I would highly suggest you go and look at each of these things, explore a bit more details about each of these things, and study some more information as well. Um, so that's mainly it for today on transport layer security. Are there any questions? Um, so if there are no questions, we may conclude the lesson for the day. So thank you for joining for today's lesson. We'll continue next week. See you. Bye.